Okay, so today we're going over the second part of Linux OS configuration. We're going to start with PAM, which stands for Pluggable Authentication Module. PAM essentially is a set of libraries that you can use and modify in order to configure user authentication. So there's three primary files that you'll want to make note of. Two of them are within the etc pam.d directory, which are the common password file and the common auth file. And then this third file, which is etc login.defs, it's not actually part of PAM, but most people do this concurrently with the other, most people configure this file concurrently because um, it modifies a lot of the same kind of things that you'll want to do for authentication. So in the PAM file, each uh, configuration is separated by lines, and similarly to how the sources.list file is, each line is separated by spaces to denote different fields. Um, this is just a short rundown of the fields that are in the PAM file, but you don't really need to know this stuff into depth. Um, you'll mostly just want to know what you need to add and modify within the PAM file in order to secure it. And then the libpam cracklib package is a PAM module that you'll want to manually install, and it'll give you a greater use of tools to configure passwords more securely. Okay, so the first file that we're going to go over is the common password file located in etc pam.d/common password. This file controls, or at least what you'll want to add is configuration to enforce stricter passwords. Um, so on the line for the pam_unix.so module, which you'll be able to locate just by looking or controlling F for pam_unix.so, you want to add remember equals 5 to the end of the line and minline equals 8. And what these keys do is remember equals 5 sets it so that your system remembers the last 5 passwords that you set on for each user. And why you might want to have that is because if the user changes their password to a password that they've already used, or to a password within the last 5 passwords that they've set, that's generally insecure because you want to have new passwords each time you change it. So with remember equals 5, you won't be able to change your password to one that you've already had within the last 5 password changes. And then minline equals 8 is pretty self-explanatory. It just sets the minimum length of the password. And then for the pam_cracklib.so module, you'll only be able to configure this if you installed the libpam cracklib package earlier with this command. So to configure the pam_cracklib.so module, you want to add these keys exactly as they are. U credit equals -1, L credit equals -1, etc. And what this configures is it makes it so that each password needs to have at least one uppercase letter, lowercase letters, number, and symbol. And then the next PAM file we're talking about is the common auth file located in etc pam.d/common auth. The common auth file, it manages how users can log in to or authenticate themselves. There's only one configuration that you'll need to add, which is this entire line. Auth required pam_tally2.so deny equals 5 on error equals fail unlock time equals 1800. Um, and what this line does essentially, uh, these first 3 fields just specify what module and what type of service you're configuring, and then deny equals 5 makes it so that the number of failed logins that you can have is 5 before you get locked out of the account. Um, and then on error equals fail, you don't really need to worry about this that much. It just means on you get an error for failing the password. And then unlock underscore time equals 1800 means the amount of time that you have to wait after you get locked out in order to try logging in again, which is in seconds, so which is 30 minutes. One thing that you should be careful about with this file is that you don't get locked out. As you can see, if you type in a wrong password 5 times while you're trying to log into a user, you will get locked out for however long you set unlock underscore time equal to. So potentially you can get locked out of an account or for 30 minutes, and that could be very detrimental as you could lose a lot of progress. And there are ways to get around this. Like you can go into recovery mode to unlock your account. Uh, I'll probably go over that in a later lecture maybe, but you'll generally want to avoid like uh, getting yourself locked out. And if you really just make a ton of typos and you know that you have a high probability of getting locked out, you should maybe consider configuring this file like after you've done a lot more stuff on the system so that you won't get locked out if you type a wrong password 5 or 6 times. Okay, and then the next file we're going to go over is etc login.defs. This just this is somewhat similar to the change command, if you remember from the last OS configuration lecture we had, or actually no, that was the user configuration lecture. Um, Essentially, the difference between the login.defs file and the change command is that the login.defs file uh, determines the default values for every user that you create or delete. And the change command is specific to the user that you specify. So when you create a user, uh, their fields will be whatever this is in the login.defs file. And the only pertinent or the main configurations that you'll need to make is pass underscore max underscore days. And you'll want to set that to 90 days, which means you can only keep your password for 90 days before it expires. And then pass underscore min days, which is just the minimum amount of time that you can change a password after you've already set one. Uh, pass underscore warn underscore age is the number of days before your password expires that the system starts to warn you about it. Okay, and so I'm going to show you exactly how you might configure these. As I mentioned though, it's really just like modifying the files and adding lines to them, but I'll just show you exactly what that looks like during the competition. Okay. Uh, I'm assuming you guys can see my VM. If you can't, just say something, please. Okay. Okay, so first we'll look at the common password file. I'm gonna open a terminal and enlarge this. So you want to edit these files using sudo because generally their permissions are configured so that only root can edit them. Uh, so you can use the sudo command to edit them. So this is the common password file. As you can see, a lot of it is commented out. Like the majority of it is commented out, so you don't really have to worry about anything that's commented out. But here you can see what configuration lines in PAM files actually look like. Here you have the type, you have some flags here, and then you have the name of the module, and you have more arguments here. So what you'll want to do, which I already have on this VM configured, is you want to add these 2 lines to the end of the pim underscore unix.so module. So like if, for example, this file was super long, which is unlikely, but if it was, then you can just control F for pim underscore unix.so. And then at the end of this line, you'll add remember equals 5, minlen equals 8. And then, oh, and so I don't have libpam cracklib installed, so there's no pam underscore cracklib.so. So if I install, mm, oh, wow, it's not an underscore. Okay, now that I've installed it, you can see we have the pim_cracklib.so line. So with this, you can add what I mentioned on the slides. U credit equals -1, L credit equals -1, D credit equals -1, O credit equals -1. And as I mentioned earlier, what that does is it just makes it so that when you create a password, it has to have at least one number, letter, or number, uppercase letter, lowercase letter, and symbol. Oops. Okay, so that's how you configure the common password file, and you can just save it, and the configuration will it'll already go through. And then the next file, common auth. So all you have to do for this one, as mentioned earlier, is you add to the end of the file auth required pam_tally2.so deny equals 5 on air equals fail unlock time equals 1800. That looks about right. And I'm not actually going to say this because I don't want to get locked out by accident. But once you've added this line to the common auth file, then you just save, and the changes are already saved by then. And then the login.defs file. Oh, I didn't even use sudo for that, so it wouldn't have saved anyway. But so this one is kind of long, so it might benefit you to utilize some kind of search feature. By default, this number is like absurdly huge, so you'll almost always want to change this to like 90. One thing to keep in mind though is CyberPatriot will not like dock points or not give you points if your configuration is more secure than it needs to be. So you could do like 10 or something and you would still get points for it. You could do 30 and you'd still get points, but um, it's really up to you. 90 is probably like the maximum that they'll give you points for, and then you can go down from there. Past max days 90, past min days 10, and then past warn age 7. So that's all good. One thing to note is that the configuration that I've showed you guys isn't fully in depth. Just for the sake of preserving CyberPatriot rules, I can't show you guys like every single vulnerability that they might have. So what you should really consider doing is looking up like Linux security checklists or like Linux security hardening guides. One super useful resource are the CIS checklists. And most of those will go into a bit more depth about the PAM files, so you can find more configuration and more modifications that you may want to make. Okay, I'm gonna go back to the slides. Okay, so next we're gonna talk about LightDM. LightDM is the Ubuntu display manager, so it basically controls what you see here on the login page. Um, Bear in mind, this will not apply to Debian because this LightDM is only the Ubuntu display manager. And what you want to do with LightDM is disable the guest user. As you can see here, by default, there will be a guest user on the system, and they generally just pose a security risk because you don't have to have a password to log into them. Yeah, so you'll want to disable the guest user, and you can do that using LightDM. There are like so there's the etc lightdm.conf file, which is what you'll want to be editing mostly if you want to make your own configurations. But there's also the etc lightdm.conf.d folder. By the way, you can tell it's a folder because it ends with a slash. Um, and this folder sometimes will have additional configuration. Sometimes CyberPatriot may add their own insecure configuration and hide it within this folder. So you want to first check that there's nothing malicious inside here, and then add your own configuration into the lightdm.conf file. And the configuration that you'll need to add is just allow-guest equals false. As you can probably imagine, it just disables the guest user. And then you restart the LightDM service with service LightDM restart. Okay, I'll show you guys what that looks like. Okay, so this file again, you'll need to edit with as root. So you just edit this file. I'll show you exactly where it is actually. So in the etc lithium folder, you'll have lithium.conf.d, and then you'll have this folder like I told you. But in this example, there's nothing in this folder, which is good. So we'll edit the lithium.conf. And here's what I have in this file now. As you can see, it's insecure because it allows the guest user. So all I have to do is, I don't think I went in here with sudo. Yeah, I didn't. So all you have to do is change the true to false. If there's nothing in this file, for example, if it's empty, the guest user probably will still be there. So you'll need to just create this file on your own, and that's all you need to do is add the seat defaults tag, and then write the allow guest equals false yourself. And now if I, oh, okay, I'll just show you guys. So here, I'm gonna exit out of the session. Oops. And I haven't saved my changes for that file yet because I just want to show you guys what my login screen looks like now. So you can see here, the guest session is right here. I could log in here if I wanted to, but I'm not gonna. And this is before before I saved my changes to the lithium.conf file, or no, before I restarted the service. So now if I restart the service, after having made that change to disable the allow guest, see now there's no guest session, and that's the secure configuration that you'll want to have. Okay, next thing we're going to look at is sysctl. Sysctl is somewhat like ambiguous. Like there's a lot of configuration in this file, and you will not need to know exactly what each line does unless it's for like a forensic question or something. But generally, you'll just need to know what you need to add to this file. And what the file is it's a configuration file that modifies and reads attributes from the system kernel. So it can do stuff like disable IPv6 and lots of other configuration that you won't need to go into much depth into. Some notable configuration, these are things that will almost always give you points if they're configured badly. There's net IPv4 TCP SYNAC retries equals 2, TCP RFC 1337 equals 1, kernel randomized VA space equals 2, echo ignore broadcast equals 1. So in order to make changes to this file, all you have to do is replace whatever value you have in the file with whatever the correct value is. Or if the line doesn't exist, you just add the line yourself. And then after you've made the changes, then you'll go back to your terminal and just run the sysctl-p command, and that will save your changes. I'll show you guys what that looks like again. By the way, the slides are on the website, so oh yeah, okay. So most of the lines are going to be commented out. Okay, so as you can see here, like a bunch of these lines are commented out. Some of them might actually have the correct configuration, but like because your kernel doesn't read any lines that are commented out, you can likely just add them yourself. So I'll just show you an example of like the first one, net IPv4 TCP underscore SYNAC under retries equals 2. And it might get kind of long to have to type all these. So another thing you can do is have your team create your own like secure sysctl file, and then during the competition, have it open and copy everything over. So that's the first line of configuration, as you can see. If this already existed but it was commented out or something, then you would just uncomment it, or you could just like add it again. It doesn't make a difference really, but whatever floats your boat. And then after you make the change, then you do sysctl-p with sudo. And it'll print out all the lines that are in the configuration. There's only one because there was only actually one. That was the one line that I added to the file because everything else is commented out. Okay, next is grub. Grub is the GNOME bootloader, the GNU bootloader, and what it does is it loads the kernel into memory. Uh, you don't need to concern yourself too much with what it does, but what you'll need to do to secure it is create an encrypted password and set the super user equal to root. And the way you do this is with the grub-makepassword-pbkdf2 command. And what this command will do is it'll just prompt you to to input a password, and then it'll encrypt it uh, using pbkdf2, and then you'll copy that password that it generates and put it inside the grub.d /00 header file. And inside this file, you want to go to the very end and add these 4 lines. So if you go to the presentation yourself, you can see for yourself, but there's the cat and then 2 less than signs, end of file, which is EOF. There's set super user equal to root, and then password pbkdf2 space root space, and then you paste here where it says encrypted password, you want to paste the password that it generated from the grub make password pbkdf2 command. So after you run that command, you copy the output and then you paste it onto this part of the 4 lines that you're adding. And then after you've made that change to the 00 header file, then you'll run the sudo update grub command. I should mention this also you need to run in sudo. Okay, and I'll show you guys again exactly how you do that. So I run the sudo grub make password pbkdf2, and now I can just type in my own password. It doesn't really matter. There's no like requirements that you'll need. And then see, this is the output of the command, and you'll want to copy this part of it. So this part of it is your actual hashed password. And then now that you have it, you edit the etc grub.d /00 header file. And you go to the very end, and I already have these 4 lines written here, but you won't have them normally. Normally, like there just won't be any of these 4 lines at the end of the file, so you'll need to write them yourself. Uh, okay, so like you go to here, you replace the encrypted password with whatever your actual password is, and then you just save it, and then update grub. And I'm just not going to do it right now because it takes a little bit of time. Okay, next thing we're going to talk about is IP spoofing. IP spoofing is essentially sending a packet to some host with a fake IP address. So modifying your IP. So it's commonly used in distributed denial of service attacks or DDoS attacks because an attacker will want to like vary their IP address when they send their requests to like confuse whoever is receiving the attack. Um, and in order to secure your host from this, although it's not really completely secure, it just adds a layer of security. You'll modify the etc host.conf file, and you want these 3 lines present: order, bind, comma, host, no spoof on, and multi off. If any of these have like different configurations, like if, for example, if it was order, host, comma, bind, then you would change it to bind, comma, host. And if it's no spoof off, then you would change it to on. And what you'll commonly see is that the file will have multi on in it. So you'll want to obviously change that to off. And what each of these does is the order just specifies the order in which your host performs lookups. No spoof prevents host name spoofing, so like changing the host name, and then multi off. Multi is like, or no, it's like from the Resolve Plus library, which you don't need to worry about. It makes it so that you only return the first valid address that you find for a host when you're performing the host lookup. Um, yeah, you don't really need to worry much about what each of these lines do. You just need to know what configuration you need to have. And as I mentioned, it's in the etc host.conf file. And I can just show that too. Okay. Um, so if I edit this file, you can see right now what it looks like is order host comma bind. So I want to change this to bind comma host, and this is multi on, so I want to change this to off, and then I'll add the no spoof on line, and then save it. And after you save it, it's already, the changes are made, so you don't need to run any command. Okay. The next thing or the final thing we're gonna go over is file permissions and ownership. Um, File permissions can be a bit confusing at first, but after you understand how it works, it makes a lot of sense, or it's very intuitive. So you probably just know from guessing that file permissions control who can read files or who can modify files, stuff like that. So on Linux, the three main permissions that you'll have are read, write, and execute. So read and write are self-explanatory, and then execute just means that you can run the file if it's some kind of executable, like a shell file or an like an LSU binary file or something. Uh, and in order to list the permissions of a file, you'll use the ls-l command. You may already know that the ls command just lists the context of the directory, and the -l flag gives you a longer version of it. So I'm actually going to change this to ls-l file. And once you add this file, or once you add the file name to the end of the command, it only shows you the contents of the file. So the -l, like I said, it means long, so it shows you a bunch of more attributes about the file. Generally, if you omit the -l, it just shows you the name of the file, I think. Um, yeah, it just shows you the name. But if you add the -l, it shows you all the permissions. It shows you the owner and the group, and it also shows you some other stuff like the size of the file and what time and day it was created. So that's how you'll view the permissions of a file or a directory. You just use the ls-l command, and then you can choose to write a specific file or directory here, and it will only show you the contents or the long output of one. So I have the output of the ls-l command here on the right. It's cut off a bit because you don't need to worry about anything after these two fields, because after that it just shows you the size of the file and then what time it was created and what day. So you don't need to worry about that for the sake of file permissions and ownership. It's only these first four fields which are necessary to know. Um, so you can see this like long string of dashes and letters. And what this means is, so each dash denotes a permission, and the dash can be replaced with a letter or just kept as a dash. So the first dash represents what kind of file it is. If it's a file, then it'll just have a dash. If it's a directory, it'll have a D. Um, and then the subsequent fields are all grouped in threes. So these three are all grouped together. These three are all grouped together. Okay, you can see by the colors. Yellow is grouped together, blue is grouped together, and then this purple pink is grouped together. And what each of these denote is owner, group, and other. So the owner of a file is whoever made it, or like by default, it's whoever made it. And then the group is the group of whoever made it. Um, and then other corresponds to anyone that isn't the owner or isn't in the group. So another way to find out or to see this is that the group is the second or this last field right here, and the owner is the first field. It might be a bit confusing because they're both root, but there's essentially our root group and then there's the root user. So this first field means the owner is the root user, and the second field means the group is the root group. So as I mentioned, the permissions are grouped in threes by the owner, group, and other. So these first three permissions all correspond to the permissions that the owner of the file has. And the second three correspond to the permissions that any user who's in the group of the same file has. And then the last three permissions are for anyone that isn't in the group or isn't the owner. And that's what permissions they'll have to on this file. So if we just look at the example of this output here, we see an R and then a W and then a dash. I can just tell you now as I mentioned earlier, the three permissions are read, write, and execute. Read is R, write is W, and execute is X. So if the owner had the execute permission on this file, this would instead be a RWX if he had all three of those permissions. But right now it's just RW and then dash, meaning the owner can read the file and write the file, but he cannot execute the file. And then these next three letters or characters correspond to the group. And the group, as you see here, is the root group. So members within the root group can read the file, they can't write it, and they can't execute it. And then for anyone that doesn't fall under those two specifications, they can read the file, but they can't write or execute it either. So that's how you interpret the ls-l. That's how you interpret the permissions of the file. When you're setting permissions, however, you'll use the chmod command or chmod, and then you can add this dash capital R if it's a directory. And if it's a directory, then using the dash capital R will permeate all the permissions that you set to every subchild and subdirectory and subfile within the directory. So it stands for recursive, so that makes sense. And then after the dash R, if you choose to have it, you can add the arguments, which is just the permissions terms also. So right after the dash R, you specify what kind of permissions you want to set the file to have. And then the last field is the name of the file. So how you create or set permissions, there's two distinct ways. You can use the letters RWX, or you can use octal. And octal is the base 8 number system. So I'll explain how this works in a second. But as I mentioned earlier, the permissions are separated into three groups, right? So there's owner, group, and other. How you interpret it using the chmod command is user, group, and other. So user just corresponds to the owner. Just pretend those are synonymous. So and the user, group, and other, these three will have the key letters of U, G, and O, respectively, just as how read, write, and execute is RWX. So if you look at this example I have down here, uh, the chmod command, is right here, and then these are the permissions. Oh, and there's no file, so I'll just say out.txt is the file. So these are the permissions. Using the first method of read, write, and execute, you can add permissions by specifying first whether it's specific to the user, group, or other. So here I have an O, which means that it's specific to the to other, and then I have a minus, and then RWX. And what this does is it removes the read, write, and execute permissions from the other. So so if you look at this example or the output right here, other currently has the read permission, but doesn't have write or execute. So this would just get rid of the read permission because it doesn't have these two to begin with. And then you can concatenate permissions by using a comma. And then here's the second one is G equals. So you saw earlier, you can use the minus, you can also use the plus, and you can also use the equals. Equals will just wipe the current permissions and set it equal to whatever you have. So G equals WX means that the group will have the permission to write and execute. And then to change the owner and the group of the file is pretty simple. You just use the chown command, and you can add their cursor flag if you want. And then you have the user separated by a colon, and then the group, and then the name of the file. And I mentioned earlier, you can also use octal to determine or to set file permissions. And the way octal works is you will have a 3-digit number. The first digit corresponds to the permissions of the user. The second digit corresponds to the permissions of the group, and then the third digit is for other. And each digit, it represents the sum of these three numbers. So read has a value of 4, write has a value of 2, and then execute has a value of 1. So if I wanted to give like the group read, write, and execute, you add up these three numbers, which is 7, and that would be the middle digit. That would be the second digit because it goes user, group, and other. If I wanted the user to only have read, I would just make the first digit 4. If I wanted if I wanted the user, group, and other to only have read, it would be 4, 4, 4. And I made this little table so you can kind of see some examples. So for example, if I want the user to be able to read, write, and execute, and the group to execute, and other to not have any permissions, I can use this first notation, which is u equals rwx, comma, group equals x, comma, other equals nothing, and that just means it has none. Or I can use octal, and the number would be 710 because the first digit corresponds to the user. And since it's read, write, and execute, that's 4 plus 2 plus 1 equals 7. And then group is execute. So that's just 1 because execute has a value of 1. And then other is none, so it's 0. And then another example, user read, group write, other execute. It would look like this with the RWX notation, and then 4, 2, 1. If I wanted to change it so that like group has write and execute, that would be 3 because write has a value of 2 and execute has a value of 1, so it would be 3 for group only. And then this last example is if you want to add permissions, you can't add permissions using octal because it only sets values for the permission. So you would only be able to add permissions with the RWX syntax, and that would use the plus operator, adding R and X to the O to other. Okay. And here is a list of files that are generally important and will give you points if you configure the permissions correctly. You have the etc password file. What you'll want to have, the user should have, or the permissions is 644, meaning the user can read and write. The group can only read and others can only read too. And the owner is root and the group is root. And then the shadow file, the owner of the file can read and write. The group can only read and others don't have any permission at all. And the owner would be root and the group is shadow, and etc. for these 5 files. And generally, if the permissions are configured incorrectly, if you change them, you'll likely get points. There's not really any time for practice, but I'll just try to go through these really quickly. Make file run.sh executable for every user. There's 2 ways, or there's only one way to do this actually, because if you want to add an executable permission, you need to use the plus operator, and that's only available if you're using the RWX notation. So it would just be UGO, meaning for every group you want to add the executable to the run.sh file. And then make directory dir1 readable by all users, executable only by users within the group, and writable only by the owner. This one is slightly complicated, but the permission is on the slide also if you want to look at this later. And then make file test.txt have owner, radius, and group admins. You just have them separated by colon with the owner and the group. Okay, yeah, that's all. Thank you guys.
Thank you for coming, everybody. Bye.